Hello everyone, welcome back to the channel. This is Shailesh SH. For the NEET 2026 exam, some important topic I am choosing. Based on that, we are going to discuss some questions also. So let's go for the chapter this alcohol, phenols and ethers. In this, I am going to explain you about the oxymercuration, demercuration reaction. Oxymercuration and demercuration reaction. Try to understand most important characteristics of this reaction. I will just explain based on the reactions only. First, try to understand what is this. In this oxymercuration demercuration reaction, we are trying to convert the alkene into alcohol derivative. You may think that only this much reaction, yes, this much only, but based on the mechanism they may ask. Reagents are important. Here we are going to use the mercury acetate in the presence of water, along with we are going to use the sodium borohydride, NaBH4. So let's understand the mechanism. Based on that only you will understand how they can ask the question. We know that alkene is a very good electron donor because it is having some electron density within itself, in which whatever the reagent I am using, mercury acetate, I can write this one as HgO C double bond O CH3 like this, right? This also I can mention like this because twice is there. So here I am trying to dissociate this bond, then it is going to break. The product is supposed to be this bond. I shifted this way. This side means oxygen will get negative charge, so we got acetate plus electrophile is going to act as mercury acetate, that is HgOAC. This is we mentioned as it is, so it act as a electrophile. I told now only that alkene is a good electron rich species, so it need to attack to the electrophile. What we have electrophile, that is mercury acetate. So here we are going to get the attacking of alkene on the positive charged species. So it is going to make a three-membered ring. There is a transition state of Hg acetate, that is mercury acetate. Now this electron is shifted towards this one, means obviously there is a positive charge on the center carbon because secondary is more stable carbocation compared to primary. Here we get negative charge. So to this, again, if you are trying to add now water, I am trying to explain this characteristics later by some points. You just try to understand mechanism. Here addition of water takes place. This lone pair obviously will go and attack to the opposite direction. That's the reason we call it as it is anti-addition. You keep in mind this one first. Alright. So in this anti-addition, water is going to attack in the opposite direction because it is having positive and oxygen is having lone pair. So we got the product like this. Oxygen donated its lone pair, so positive charge will form. Then remaining CH2 will get only mercury acetate. So interesting thing is that this positive charge is going to be neutralized by the electrons which make the bond with the CH plus. So why we call this reaction as a oxymercuration and demercuration? Keep in mind here reactant initially it was having only alkenes, but now to this alkene one carbon is having the oxygen derivative, that's why we call it as oxy. Another side we are having mercuric derivative, therefore we call it as oxymercuration. Just I am explaining the remaining things, try to understand. Further, positive charge on the oxygen is most unstable actually, because more electronegative element with the positive charge is unstable, therefore that hydrogen will donate its electron and it will dissociate it as H plus, come out as H plus. So we got RCH and OH, then remaining part will be as it is CH2 and HgOAC. This is the step 1, we will get the product. But what is the use of NaBH4, right? We have second step. NaBH4 generally dissociated as NaBH3, sorry, Na plus BH4 minus, like this it dissociate. Then BH4 minus dissociated as BH3 plus H minus. This is a step 2. So generally what happened next? Whatever the product I got, RCH CH2, in the center carbon it is having tertiary alcohol, then remaining part is HgOAc. Reaction name is oxymercuration and demercuration, right? I told now only that because of OH is addition takes place, we call it as oxy addition, and another one side is mercury derivative is added, therefore we call it as oxymercuration. But why we are calling continuously demercuration? Because whatever the mercury derivative is attached, it is now is going to detach from the substrate or reactant side. So after that, Hg plus is going to Hg is going to dissociated from this. Then OAC, nothing but acetate. Can I write like this? OC double bond CH3. So here this a bond is shifted to Hg, and Hg is going to break this bond and shift it towards the oxygen. Then finally Hg come out as with a zero oxidation state. Then what left here? RCHOH. This CH2 and Hg dissociated means this only we call it as demercuration. D means what? Removal. What? Mercury derivative is removed. So this will get positive charge, and the CH2 plus on the terminal carbon, whatever we got, keep in mind H minus of NaBH4 will come and attack on the terminal carbon. Therefore, product is going to be this CH2 does not come from the acetate derivative or any other side. It will come out always from the NaBH4 side only. So this H come from where? From sodium borohydride. Keep in mind OH come from water. So remaining product as it is, we have Hg along with acetate derivative. So finally we got the product of what? Here indirectly or directly we can say oxymercuration demercuration is nothing but addition of water only. You can see here also OH on the center carbon, H on the terminal carbon. Therefore we call it as this reaction is addition of water, which follows Markovnikov's rule. Keep in mind. So what are the important characteristics? So here they can ask the question from any other points. Characteristics of oxymercuration demercuration. First of all, it is addition of water on alkene by the Markovnikov's rule, as I told now only. And here partial carbopositive charge, nothing but non-classical carbocation is used in the reaction. And keep in mind, important thing is that there is not at all rearrangement of carbocation takes place. Don't make any rearrangement. For this, it is anti-addition reaction. So let's understand some questions, then we'll wind up the class. First question is that I have this 5-membered ring with the alkene derivative. Keep in mind, based on the reagent only, you can decide that whether this reaction belongs to what type. So they added the reagent, and now they're asking what is the product. Generally what I told, there is no rearrangement first of all, right? So how to solve this one? Understand first. HgOAc, mercury acetate is there in the presence of water. I clearly mentioned that break the bond of double bond, unsymmetric will be there. To this, if I shift a double bond, then we'll get the positive charge. Secondary is more stable, that's why I'm making like this. You can convert like this, then positive charge will be on the terminal, then that become primary carbocation. So secondary is more stable, that's why I made like this. After this, add the water directly. OH will come out and attack on the center carbon, that we will get the product of secondary alcohol. Keep in mind, I repeat one more time. And here in the mechanism through, if I goes, I got HgOAc, right? So I dissociated this one, it will get a positive charge, and from NaBH4 H minus will come and it will attack on this, demercuration will takes place. The final product is going to be like this. Here CH2 will be there, but one more H always come from NaBH4. So product is CH3 derivative only. Sorry, alcohol derivative, and the terminal carbon. Generally we will write CH3, but that H come from where? That H come from NaBH4. You don't forget this one. This is the answer for this. I hope you understood the question. Example number 2. CH3 CH double bond CH2. Same reagent, what could be the product? Try to solve yourself. Again, same reactant, Take it as a homework. Let me know the answer in the same reactant. Simply for your understanding purpose, I am mentioning one more important thing here is that whatever question I told now, if it is H plus and water, now find out what is the product for this. If you need the answer, just comment below, then I can explain in another videos. So here I am trying to add now Hg, OAC twice, water and sodium borohydride. What is the product for this? Or else you can mention what are A and B. Related to this, I will just mention some more questions in the shorts I am trying to upload. Just try to watch and practice yourself. Thank you for your time. Jai Hind.